Now we've already seen that you can solve systems by graphing, but that usually gives us an approximate answer, and we have to check to make sure that the point that we think is on the graphs of the two equations is actually a solution. So here's an algebraic way to solve a system. This is the method of addition. And the way this works is we make sure that both variables are on the same side of the equation. So x plus 2y equals 5 and x minus y equals -1. And then what you want to do is add or subtract the two equations in order to eliminate one of the variables. What I'm going to do is if I subtract the second equation, then I'll notice that x minus x is 0x, so the x coordinate goes away completely. So let me subtract the left-hand side and subtract the right-hand side. Let me just rewrite what I've got here. X plus 2y equals 5, and then negative x plus y equals a +1. Now, if I was smart and lined up all my variables and all my like terms together, then this should go quite easy. X minus x is 0. It eliminates the x. 2y plus y is 3y. And 5 plus 1 is 6. So this gives me a new equation in just one variable to solve. Divide both sides by 3, and I've got y equals 2. So this gives me the y coordinate of the solution. And now what I can do is take that number and plug it back into either one of these two equations and solve for x. I don't think it matters which one. I'll just do the first one. The equation is x plus 2y equals 5, and I'm going to plug 2 in for y. So x plus 2 times 2 equals 5. That's x plus 4. And then if I subtract 4 from both sides, you get minus 4, you get x equals 1. So now I have my solution. The x coordinate is 1, the y coordinate is 2, and there's my ordered pair that's a solution to this system. Let's look at another example that requires just a little bit more work. 3x minus 2y equals 3, and 2x plus 3y equals 2. So notice that the coefficients of the x's are different, and also the coefficients of the y's are different. So what I can do in this case is multiply the entire equation, both left-hand and right-hand side, by a number that will make it so that one of the variables has the same coefficient. So let's see. If I multiply the top equation by 3, the y coefficient would be 6. And if I multiply the bottom equation by 2, I would get a 6 coefficient here for y. So let's go ahead and do that. I'm going to put this whole thing in parentheses and say times 3, and the second equation in parentheses and say times 2. Let's make sure that we distribute into both sides of the equation. So the top equation becomes 9x minus 6y equals 9. And the bottom equation becomes 4x plus 6y equals 4. So now notice I've got minus 6y plus 6y. So the y's are going to go away. So I'm just going to go ahead and add these two equations together. 9x plus 4x gives me 13x. Again, by design, negative 6y plus 6y is 0, so that goes away. And then 9 plus 4 is 13. Divide both sides by 13, and I get x equals 1. Wonderful. And then let's go ahead and plug that into either one of these two equations. I'll start with the first one. 3x minus 2y equals 3. Let's plug in x equals 1. 3 times 1 minus 2y equals 3. And let's solve for y. 3 minus 2y let's subtract 3 from both sides. Ooh, I get negative 2y equals 3 minus 3 is 0. And now let's divide both sides by negative 2. Y equals 0. So now I have my solution. Some people freak out just because there's a 0, but it's okay, it's a number. X is 1, y is 0, and there's the solution to the system.